First hour, starting with 5. Okay, let me bump this up a little bit. We're starting with 5. Okay, we have f of x and g of x. We're finding f times g of x. So basically what I'm doing here is I'm taking my f of x polynomial and I'm multiplying it times g of x. Most of you, I'm assuming, for this are heading to a box. But if not, that's okay. But all I have to do is multiply this one out and make sure I combine like terms. So in this one, again, make sure you're adding your exponents when you multiply. And again, the nice thing about the box is if you have like terms, they're going to keep combining in the diagonals that are here. So this one, 4 and 2 is 6x squared. Don't mess with the exponents anymore once your box is filled. Minus 3 is negative 1. Boom. So the difference between 5 and 6 is we're multiplying on 5. 6, we're actually substituting the one function into the other. But that's where my difference would be. I see number 13, Thursday. Okay. Graph 2 examples of functions whose inverses are also functions. What test do I have to be able to pass the horizontal line test, okay? So I need to pass the horizontal line test. So can somebody kind of with their hands or with a finger drawing give me an idea of what type of a function might pass the horizontal line test? Okay, a parabola, like opening which way? Up, okay. Parabola opening up. Now, is that going to work? No, that doesn't pass. No. Okay. They're like, Hardy, and you're doing it in 10. A straight line. Like which way? Okay. I could draw a vertical line. That would only cross at one point if I did a horizontal line test. That would work. Oh. A linear expression, otherwise known to most of us as a line. Okay? But yes, that would work. Even if some of you that were talking about, because when Ben had mentioned a parabola, that would work if I made it sideways. Okay? It just won't work if I use it up or down. So as long as my whatever drawing I make passes the horizontal line test, I'm okay. What else? 31. I had a feeling. Okay, we're gonna hunker down here for about 5 minutes. Here we go. 31. We are gonna basically review everything we've done with graphing.
Oh my God.
Now, when I do this one, we'll get the calculator working on the side here. Make sure that you take enough time to get this typed in carefully because we don't want to go to all this work and then, I knew this one was coming. So once I get it in, okay, I'm going to go ahead, I'm going to hit graph. Okay, so now, some of you, when you punch this in and hit graph, you're like, that's not what mine looks like. Because if you do yours, I'm not letting you see my window here for a minute. Because I want you to kind of see some of the work that goes in here. Okay, I'm assuming what yours is going to look like once you punch it in. Okay, let's answer the first couple of questions before we start doing the fancy stuff. What degree is this polynomial? 4. It's just the largest exponent that I see. Okay. What about the leading coefficient? 1, it's just the number that's in front. Now here's what gets interesting. Okay, name all the zeros. How many should there be? Okay, there should be 4 answers. There should be 4 zeros, because that's what my degree is. If I look at the calculator, there's 1, there's 2, there's 1 coming, it looks like through at 0, we'll find out in a minute, and there's 1 over here. So I can see them all. There's no imaginary ones this time. Let's see if the table gives me any freebies. There's 1 freebie. 0. Okay. I don't think we get any other freebies. Doesn't look that way. Double check. No other freebies. So I come back to the graph. I'm like, okay, I need to track the other zeros. So you start looking, you're like, okay, trap the zeros. So second trace. I want zeros. Okay, that's number 2. Same thing as calling them intercepts. So bump this up a little bit so you can see a little easier here. Since I'm here at the middle anyway, I'm going to go ahead and I'm going to grab this guy first. He's kind of close. Now, one thing some of you may notice, and Ben opened our eyes up to this the other day, zoom is an option here. Now, sometimes it zooms a little too close for comfort. So again, anytime I'm trying to find this particular intercept, okay, notice my blinky guy, he's still here. He's just down here. I can use that. Anywhere, if I'm heading up, anywhere below, and anywhere above my line, okay, I'm trapping into this middle portion. So if I do that, okay, my 0, and it asks us to round to the nearest 100, so I have one at negative 2.12. That's one of them. I still have this one on the right and this one on the left to deal with. So we reset here. So second trace, my 0. I'm going to do the one over here next. You're like, why is he avoiding the one to the left? You will see soon. Okay. Again, here, anywhere below and anywhere above is fine since it's increasing. So I'll hit enter once. Okay, my blinky guy is way up here, but he's still above the line. So I'm still trapping with 1 point below and 1 point above. So I should get my 0 here. Okay, 1.31. And now the fun begins. Because you look over there, and I tried, when I was doing this originally, I tried the zoom function, and my little cursor guy would disappear. So if I go to do this one last time, alright, I'm bound and determined. Here comes the cursor guy. So I'm heading, okay, there he goes. Now he's disappeared. And I'm going. And I'm going. And I'm going. And I don't see him. And I still don't see him. What the heck? Now what do I do? Okay, no, we do not quit. Okay, here's my idea. He's off the screen right now.
Should we start running back towards
So no, we don't have to do that necessarily. I'm going to go to my window. I want to see the whole graph at one time because when I'm thinking about maximums and minimums later, I need to see what this is going to look like. So since it looks like it's going down quite a ways, so I look at this and I'm like, it's even going above the screen here. I'm going to change my window. I'm not going to mess with X, but the Y's I'm going to make a little bigger. So maybe if I do like negative, whoops, not negative 0. Negative 50, whoa. Negative 50 to 50, let's say. Let's try that. Dang, that doesn't even do it. Well, now I see this part, so that's good. But negative 200, okay. Negative 200 graph. Almost. Woo! Okay, I finally can see everything. So, now let's do second trace and go find our 0. And the nice thing is, at least I'm going to be able to see the cursor the entire time. Now you're like, wait a minute though. He kind of disappears into my left bound. since I'm trying to trap that point down there, okay, I start coming up, and I'm like, uh-oh, he disappeared again. Okay? Remember, though, when I'm looking for a 0, the only thing I have to do is make sure I get the x-axis trapped, that I do one above and one below. Since this is decreasing, if I hit left one more time here, I'm like, is that above? Yes, it actually is, because the y value is at 11. So I can hit enter here. Then I hit it once and I'm below. I'm trapping it at that point. Where? Now, let me ask, when you're trapping on this one, were you doing it above and below, or were you doing below and above? Because that matters. When you're doing a 0, okay, here's the difference. When we were doing this, I got to do this so it shows up. When we were finding the zeros here and here, okay, notice the graph was increasing. There's an order to it. If it's increasing, if the line's going up when it crosses x, I do it below, and then I do it above. If the line's decreasing when it goes through the x-axis, I have to do it above the x-axis and then below. If you get an error message, try doing it the other way around. Because if my first point is above for this one, and my second point is below, you're not going to get an error message. You're going to get a 0. Okay, so if you ever get an error message where it tells you quit because you are not in the right bound, all it means is, whichever way you trapped it, you need to do it the other way. Okay, and the 0s are the only time that's going to happen. So that's the one thing you got to watch for. It's decreasing, above and below. Increasing, below and above. And like I said, if you get the wrong one, just play with it. So you're like, ugh. So now you're like, okay, now what? Well, or do we want to? Because if I want to find the max and the mins, I see these all already. So let's just do those. So I see this mins here first, so let's do that. So minimum. So I'm going down to letter E. Again, when I'm doing the min, I'm trying to trap my valley of sorts. So somewhere to the left, hit enter. Somewhere to the right here, that's good. Hit enter twice, and I have a minimum at, negative 5.57. Holy cow, negative 215.45. What the heck? Do I have any more minimums? Okay, I have one more. Let's do this one more time. I'm going to skip my maximum for a second. So I now have located myself way up here. So I'm to the left of it. Move my way around here. Now I'm to the right. Again, I'm trapping it in the middle. So my other min is at 0.76, negative 9.62. Okay, I got that locked in. How many maxes do I have? 1, right there. Well, last time we got to do this. Max. Again, left to right. So we'll get to the left of it, anywhere to the left of it. Hit enter. Anywhere to the right of my maximum. Double enter to lock it in. Negative 1.19, 16.57. So I get that. It's like, whew, what the heck? So then, it's like, okay, we got all this information. Okay, and I'm even going to leave this way because I want to think about it here in a minute, how this all works. State the intervals where the function is increasing. You're like, okay, now this is a little trickier because I can't label everything without having a picture. Well, wait a minute. Why don't I draw a picture? move this over for a minute. I'm going to take enough time here for a second to make myself a sketch. Now, it doesn't have to be perfect. Then we're just going to kind of... The reason I want to draw this is for two reasons, actually. I want to label where my maxes and mins are, just the x value. So like my first minimum, the x value is at negative 5.57. My maximum here was at negative 1.19, and my other min was at 0.76. Well, why would I want to do that? Because now, because I've seen quite a few of you go into the color scheme like I have, I can look at my decreasing, and I can physically see and mark where all of these things are going on. Because with having that available, now when I go to answer the actual question about the intervals where it's increasing and decreasing, I even have numbers there for me. Okay? My increasing is my green. It goes from negative 5.57 until I get to negative 1.19. Then it stops. Where does it increase again? Well, it starts at 0.76 and goes to infinity. When I'm doing intervals, it's about the x values. Decreasing, starting at negative infinity. And I know that's tricky because you look at it and you think it's positive, but we're not looking at the y's, we're looking at the x's. It keeps decreasing until I get to negative 5.57. Then where does it start up again? Well, it increased until here, and then it decreased again. That's why I need to take a minute to actually draw a quick sketch. Notice mine's nowhere near perfect. I mean, we know this is 200 down and this is like 10 up, but that doesn't matter to me right now. I just need a sketch so I have something to work with. And the other reason I want a sketch is for letter H. Describe the end behavior. You're like, oh, it's been a while. Hopefully you remember this business. Because now, we talked about before with end behavior, okay, as x approaches infinity, what that's asking for, in plain language, is, as this graph goes to the right, these are interchangeable as long as I have one of each. So as my graph goes to the right, what's happening to my y value? Okay, it's moving upward. So, as y increases, x is increasing. My x and y values are increasing as I go up and to the right. Well, when my x value is decreasing, okay, when it's going to the left, what's happening to my y value? It's increasing. So as y goes up, x is going left. Okay? We're just using the symbols to describe what's going on. If somebody came up and said, I don't have a calculator, describe to me what this graph looks like, you could. And then hopefully the easiest question on the test. State the domain. This never changes. All reals would work too. Negative infinity to infinity. The only one that can change is range. Range we do bottom to top. Where is the least value of y? Okay, negative 200, negative 215.4 whatever you get. Is it 8? I thought it was 5. I don't know. I won't get that cookie. But then it goes up forever. Forever. So yes, there will be the last question on the test tomorrow will look like this. Now some of the other things that are a little bit trickier, there's even going to be some multiple choice questions in there tomorrow. So that's what it is. Oh. Where are we heading next? Because we kind of got bogged down there for a little bit, but it touched everything actually. Where else do I need to head? Where are the issues? Yes, ma'am. Number 6. Back to the front we go. All right, function notation. F of g of x, which actually means... Well, but I'm not multiplying. This circle means I'm literally plugging g of x into f. In other words, g of x is x plus 1. So I'm going to evaluate f, but every time I see an x, I'm plugging this in. So here's what this looks like. I've got 4x squared, but again, every time I see x, I'm replacing it with what's in the parentheses, which is my g function, plus 2 times x, which again is what's in the parentheses, minus 3. So here's what I've got to do here. For the second one, and I'll kind of work backwards, bless you. So 2x plus 2 minus 3. I not only need to multiply this out, FOIL it, box it, don't care which, but I have to do one of them. So for this part, remember, x plus 1 squared is x plus 1, x plus 1. Don't just write x squared plus 1 or you're going to miss it. Because if I FOIL or box this out, I get x squared plus 2x, so I get 1x and 1x, plus 1. And I'm still going to multiply the 4 through to all of those terms. So 4x squared plus 8x plus 4. This is the simplified version of my first term. And once I've knocked that out, once I've multiplied that out and gotten rid of all of my parentheses, now I can go back and combine the like terms. 4 and 2 is 6 minus 3. But whenever you see function notation, you're plugging the one, literally, you're plugging that in for x in the other one. So this is literally going in here and there. Oh. Yes, 10 actually would be a little bit simpler. Because 10, I'd be doing q of p of negative 4. So p of negative 4, I'm going to stick the negative 4 in for x. So I'd have negative 4 minus 4, which is negative 8. But what's the absolute value do? It makes it positive. So this is 8 times 2. So this is really q of 16, because I figured this part out. So when I did p of negative 4, I literally just did this. So now q of 16 just means I plug a 16 in there. So 7 minus 16 is negative 9. And I'm done. See, these are the ones that we continue to want to do everything at once. If I want to do 2 steps together because I want to save time, all that's going to do is mess you up. You have to go one little piece at a time. Because doing sentences makes you think about it, makes you think about the process so you actually remember it later. Yes, sir. Number 7. Number 7, basically, we've got f of x divided by g of x. I can't reduce anything. With those pluses and minuses, those things are all bonded unless they were identical, and they're not. So I can't cancel anything. But state any domain restrictions. I can't have 0 in the denominator of a fraction. So I set that equal to not equal 0. And that tells me that I can have all reals except -1, because -1 would make this equal 0 and it'd make it undefined. Fractions are not our friend when it comes to domain. We have to do a little bit of tweaking when that happens. Which one? 27? Okay. 27. Find the roots. Okay. Here is what we're going to do. And this was kind of like when I was talking about 40 before. 27. To get a start on this one. Oops, let me get my window back to normal here. Alright, so we got x cubed plus 7x squared 19x plus 21. Okay. So we're going to graph. It says find all the roots. You're like, find all the roots? What the heck? It looks like I've only got to deal with 1 here. Remember though, I know there are 3. I only see 1, so what looks like it's going to happen this time? Imaginary roots. So, I find my one that I can get from my chart, -3, 0, so I have a root at -3. So now what? Use synthetic division to rewrite the polynomial as a factor of a linear and a quadratic. In other words, something that has x and something that has x squared. This, if I wrote it as a factor of a polynomial, would be x plus 3. Because again, when you get an answer, it's the opposite sign of what we've been doing. The synthetic division part, I'm like, okay, -3 goes in the box. Don't have any holes to deal with. And I'm just going to use the synthetic division. Drop it down, multiply, add it, multiply, add it, multiply, add it. So how do I figure out the variables now? Because now I'm going to go down to x squared. I go down 1 degree, then x, and then 7. This isn't factorable, but look, guess what? There's my linear factor. Oh, sweet. That's my quadratic. So the answer for this part would be x plus 3, x squared plus 4x plus 7. That's as far as I can factor it. That's a factor of a linear and a quadratic. Linear has an exponent of 1, quadratic an exponent of 2. And then finally, it says use the quadratic formula to find the remaining roots. Before some of you have a coronary, you're not going to get stuck doing that tomorrow. So the quadratic formula, I'm going to factor this. Since I can't factor it, I've got -b plus or minus the square root of b squared minus 4ac all over 2a. So I go knock this out. 4 squared is 16. 4 times 1 times 7 is 28. And now you see where the imaginary is coming from. because I have a radical now, that's the negative. So two things to keep in mind here. Okay? 12 is 4 and 3. So normally I'd have 2 square root of 3, but what's the negative cause? I. So that's where your imaginaries would come from, but, oh my god, hard, but what? I can take a 2 out of all of those. Okay, this is what's called putting it all together. We got the root, we got to play with synthetic division, we got to play with the quadratic formula, we got to break down a radical, and we got to play with I, all in one problem. This basically is now becoming upper level math because we're starting to put things together. Now I will put one thing out there since we've only got a couple minutes left in the period. I'll be here after, okay? Again, I won't be here in the morning. So I'll be here after. 4th hour, asked about number 31 yesterday. So maybe if you look at the 4th hour video later, there might be some other ones that are available because we won't be doing that particular one in that class. We hit done.